is setting it up for the georeference and then applying the georeference, followed by just reviewing the project completed with all the multi-sensors into the georeference project with the X7. So here's just a review of the survey exercise. We see that GNSS. We have a couple locations with total stations, and in the lower left, that's the georeferenced X7 data. And that's just a review that we're just going to go highlight through a few points here. So here's the exercise review. Is we have lot 4 in this Hoover Crossing filing 2. So the survey for the exercises in the little bold highlighted area is lot 4. I will tie it to an NGS mark for geographic reference in the background for TBC and provide orthometric elevations on our site. And then also we used GNSS, and then also we used the survey is tied to some public land survey system marks per how this plat was surveyed. So that's the scope of our survey exercise, is to complete a survey of lot 4. Just reviewing now the GNSS portion for the statics. We did static sessions. We used NGS mark W410. That was a horizontal and vertical mark. And we used that to establish our site control points, 100 GPS and 101 GPS, 200 and 201 GPS. Then we followed through with some total station surveys. The points were assumed and the azimuths were assumed. And so those are off in their own little compartment. And we used the total station measurements to establish the public land survey marks. The property marks on the site worked out that this site, all but one boundary marks were in place. And then also we used the total station to establish some site control marks. And then lastly, we surveyed lot 4 using the X7. So we used the X7 to scan. This one was done with Perspective version 1. So that's we don't have any onboard georeferencing for this exercise, but it's still scan data for the site. We used flat targets for the georeferencing portion. The perspective settings, we did 2-minute scans and collected the 15 images. And then just to talk about, give some pros and cons of why we use just the X7. So using a scanner for a survey, so we look at some of the redundancy, different scans on the same locations. A good example would be building corners, getting those from different directions. Points collected, this X7 versus a total station. Lot more points with the X7 versus using a total station. And then also tracking what has been collected during the survey. Example, a detailed area where it would take you take some additional time to survey the entryway or something like that, and getting underneath some drive-through for this example. And then also the total station points requiring offset, light bulb, trees, building corners. That's some information that the X7 collect in, again, just some of the time savings. And then looking at on the con side of things is the total station GNSS are still required to set control points. X7 establishing control points, setting up unknown points, measuring longer distances to prisms and etc. And then also the debris and gutters, water in depressions, snow, etc. where the data can't be captured. So those are just some pros and cons of just using the X7 to survey a lot. And then we'll step now into the TBC project details. So we have our coordinate system, Colorado State Plain North Zone, Geo818. And then TBC, what has been completed so far? So what's been completed is that we've imported the W410 data sheet. And we can see that in the upper left corner there, W410, imported the T0 GNSS files. And in this case, this site location, turns out there was a core station pretty much across the street, just a little easterly, but we had a core site nearby. We implemented that as well. And then also the GNSS baselines have been processed already. And then also in the TBC, we're using a local site. The local site settings, the location is point W410, and we are using ground coordinates from this site. So we have ground coordinates in the project as well. And then we'll just review the demonstrations, what's going to happen in the demonstrations. Demonstration 1, we're going to combine the GNSS data with total station. So we'll move our total station to the GNSS location, perform a network adjust, review the ALTA and SPS report, the tolerance report we have in Business Center, and then we'll just then reference a couple background PDF images for this first project, first demonstration. Demonstration number 2 will just cover the registration and refine process using the X7 data. In this case, we'll complete the registration, finishing with stations 52 and 53. And then we'll just show the refinement with station 16 being fixed, all the other stations being unleveled, and then reviewing the refinement report. And then just talking about the registration process in Business Center is the site is pretty much open, not a lot of buildings, structures. We only have one building in the center of the project, but rest of it is in an open area. And we use 2-minute scans in perspective, which gives us the minimum points. And then once we, perspective gave us the green mark saying everything's okay. But once we brought it into Business Center, we found, reviewing our data, we found certain areas where the scans were out of alignment by a minimal amount, but as shown by the little diagram here is the light pole base. We had some discrepancies on scans. So the drawback is that we did 2-minute scans to get it done as quick as we could. However, with perspective software, it doesn't use all the points, and the the registration assist gave us the thumbs up for good results. But however, once we brought it into TBC, now we can see some smaller areas where the registration assist didn't successfully complete. So in this, again, this is a learning experience as well, is that we then in TBC, we unregistered all the scans and then redid the registration in Business Center. So the scans were unlinked. So in the capture in the lower left, selected all the stations, 1 through 53 we did, selected the unlink, and that unlinked all the scans. Then we proceeded to register the scans again. And then another feature in Business Center as well is we can use different scans, so we can select multiple scans to use for registration. And that's shown in the lower right is in the pairwise sections. We selected all of them, clicked the use, which unused the scans, and then we're able to go back in and say, what scans do I want to use for the scan we're registering? But we'll see that in demonstration 2. But there's just a little background on the registration and then completing it, performing the registration in Business Center.
So
Moving
Dan,
to then, yes.
would you say it's important to note that just scanning for a little longer to 4 minutes is preferred rather than 2?
Oh, yes. And then, yeah, in this scenario as well is based on our situation, being outdoors in an open area, perspective setting, 4-minute scan or higher will definitely help this situation. So again, this goes back to the best practices in planning and making sure you're using the correct settings in perspective, so we can move forward, bring it into Business Center and have not have to go through this process. Okay, moving to demonstration 3. We'll then just show the georeferencing data, moving the X7 data to the total station in GNSS. So we're using, so we'll just show a little method, different methods to do your scan points, but I use flat targets, and then we created regions for the scan point location. And then we'll see the georeference points paired, point ID and scan points, and we'll see the residuals. And just kind of just the explanation of using the flat target. So we use the keep in, keep out to isolate the target, and then selected the target, and then did a create region. So now we just have a region of the target. And then also we imported center target point. So we measured up from the ground point and created a coordinate for the center of the flat target. And then in the georeferencing tool, you match the point ID and the scan point. So if you're in a situation where you're working in creating some type of this scenario, as one little tip in View Filter Manager is turn off the raw data. So your data is at 0, 0. The raw data is up in the millions with this state plane project. And that assists the graphics when you zoom in, zoom out, that it's not zooming that 1,000,000-foot difference. So it just, you have, as shown here, your point cloud region, your region, only your one region or your target regions. So that's all what the graphics is doing. So you can zoom in, zoom out, and you can make the point pair a little easier and not make your graphics struggle. And here's just the example of what that process looks like. Is also the other tip is with the raw data turned off, you can just select the point ID from Project Explorer. So this is in the georeferencing project process, we'd select in the point ID, select it right from Project Explorer, click into the scan point location, and then we have just the region lit up, and then we can identify our center point for the scan point and pair those two together. And then following, we go through this process. Here's our 6 targets. We have them paired, and we see the residuals as well, and then we'll hit that georeference button in the demonstration. And then finally, we'll review the completed multi-sensor project with some background PDFs, and we'll just review that and show the complete process. All right, so now we'll step into the first TBC project. Is we're going to move our S7 data, which is down here in the lower left in its assume position, and then we're up here, we'll move it to our GNSS data. And then our commands we will use, we'll select our points, and then from our survey menu, we'll use just the merge point command. We'll identify that we want to move it to the GPS location 100 GPS and include 100. And then we'll continue through our other points to complete the merge. And now we've merged our assumed coordinates to our state plane coordinates. We'll recompute the project. All right, so we still have some anchored positions down here. That's just due to the fact that we have our assumed coordinate from our assumed coordinate. And we will delete our assumed coordinate, our setup coordinate from each point. Or we could disable them as well using the properties menu. We'll recompute. And now we have our total station data moved to our GNSS locations. The second step is now we want to go into our instrument setup. And what we want to do is properties. And here's our assumed azimuth. So we assume some azimuth as well. So we just want to disable our azimuth because we want to use the azimuth derived from our GNSS. And then we go to 141. We disable those, and now those are disabled for the network adjustment because those are just assumed azimuth. And we'll now step in and adjust the network. There's W410, our horizontal and vertical point, our core station across the street. And we'll adjust the network. And we'll step into our weighting. And this also has been set up just for horizontal adjustment, no vertical adjustment.
Dan, we had a question come in that said, did you already scale the GNSS points to ground?
Yes, that was using the local site settings. So 0.410, that's what brought it to ground. And we see down here is the coordinate types of the project is ground.
Cool, thanks, Dan.
Okay, so we've completed our adjustment. We applied our weighting. Reference factor is 0.97. Chi-squared is passed. We'll apply our adjustment to our project. There's our ellipses, and we'll use our manager to turn our arrow ellipses off. And so now at this stage, we've adjusted it. And now that once we have an adjusted network, depending on what type of survey you're doing, but this now gives us the option to produce the ALTA and SPS allowable tolerance report. And that's one of the requirements of this report is to have a network adjustment. So now we have the precisions between we've selected all the points. So between 163, 165, the distance, relative precision, the allowable precision, and the precision ratio. So now you have the report generated as well. So if you're doing an ALTA survey, here is the report, available report. All right, so now once we have that step is now we have what we'll have now is now we'll use our imported file section, and then we'll assign some PDFs for background reference. So this first one is a raster PDF. And then we'll use the command here. We can place in images different ways here, scale and rotation, but we're just going to use the georeference the image by selecting pixels and a point. So up here is our lot 4, oriented in a different way compared to what our survey points represent. And then we can just zoom in, add a pixel, zoom in on our first point location, our pixel. Next, our location, but we know what point that is. We can just right click, point, and then we'll add our point ID. Click OK. And then we'll just move through here. We'll select our next pixel. And then we'll add our point ID by right clicking, add the point. 160. And then we'll just add one more. And we'll go right here and right click 0.165. Click OK. Now we can compute. That gives us a little mean at how much it had to move the image. We'll close that and close that command. And now we have our lot 4 background PDF from the original plat that created this lot, showing our monument measurements from our total station, our GNSS from the core station and W410, and our control, little site control points, our PLSS monuments, one here and one is up here. And now we have an image, a background image for reference. And then we'll go here. We can toggle the visibility. Next one, we'll use a vector PDF. And so this is a vector PDF. And then with a vector PDF, it pops up and it only requires 2 points. So it's already provided for you for the box. So we can go down, select our pixel, and then you see the X appear. It's probably real small. Select that location again. We can right click, add the point. And then we can go up here. We'll select the other corner, pixel, other corner, right click, add the point, 163. Select OK, register, close. And now we have, so we have a previous survey of the lot that was recorded. And now we have a previous survey. We can check for reference. As we're doing ours, we can compare distances, and we have a nice visual aid for our survey work. All right, so that is using a couple PDFs. And now next one we have is our background maps. Here, toggle the background map. So we can enable that one, and then with a Trimble Business Center Advanced subscription, now we have, it gives us a street view, so we could use this to actually clip it out a little bit, create the vicinity map. So that gives us kind of the street view location. And then we can go to the satellite imagery by going to the Project Explorer, selecting the project name, going to the properties, and then we can change that to the digital imagery. So now we have the satellite image, and now here's our site from the digital globe imagery, our control points, our building, and our lot and our boundary lot position there. So we have some background image information as well. Okay, so that completes demonstration number 1 for bringing it all together. So now we have GNSS, our total station. And now we'll move into the second stage of the project. So here's our GNS total station, upper right. Lower left-hand corner, now we've imported X7 data. So as we see, compared to our plat that we just brought in, it's X7 data. We're rotated in a 90-degree direction. And so there is our X7 survey. So there's our 53 scans of 2 minutes going throughout the site. And now our first step is to complete the registration. And we'll use our register scans command. And then in the register scans, this kind of gives the steps of the workflow as well. Is we have the plane-based registration option, the pairwise, the cloud-to-cloud option, and then followed by refinement, with Georeference. So here's our reference stations and our moving stations, and then the registration results. But first we need to select our reference station, which we want to select our group of the ones we've already registered. And then in this scenario here, now we're going to uncheck the use option. So now we're able to select our moving station and select certain scans, and we don't have to use all of them. And then as you see, as it's going through and it's unusing the scans as the scans go into the hidden mode. And they have been deselected. So now we'll select our reference, our moving station, which will be number 52, which is shown down here in the results. And then from up top, we will select our scans that we want to use in the registration. All right, so now down below, so in the registration results now, this gives you a nice idea of what coverage you have with your reference stations and your moving stations. These colors right here, if you want to change them, these two colors are in the options section. And that hides in the option under point clouds of your reference scan and your moving color. So those are those colors there, but you can change those for your liking. And same thing up top as well is just depending on how you like to view things. We can go to true color. And if grayscale intensity, we can change that to scan color as well. But I like to work in grayscale. That's my preference. Okay, so now we'll register the scans. So we have complete register. And I always like just to get the moving station. And sorry for having to move this in the middle for the moving station, is just orient it to something that we have just a common view. So in the registration section pairwise is we have two options to register the scans. First one is doing the automatic method, or followed by picking or using 3 points. The first one for 52 will use the automatically register pair. We click that button and it does its computation. Okay, so we want to keep our adjustment. All right, so then we look at our spot down here, and then we get the little whoa. Okay, we got some good residuals, but our overlap is very low. The next step in the automatic registration is to optimize the pair. So you probably will see this result, but don't worry about that. The next step is select optimize pair registration. And it goes through there. Then it does its refining. And now the results change. So these are check pair. So these are guidelines. They're not the message presenting you to, hey, this is the results we have. This is good or bad. Just the end result. These are guidelines, is giving you, okay, is it fitting well? Okay, we have residual error. It's in the orange. We have 20% overlap. We got green. We have some. So we have our little caution message. But the end result is actually looking at your scan data once it's complete, is taking a look at items like the bollards, light pole bases, building corners. And so then we can gauge of, okay, that scan made it, even though we're in the orange value, but the end result is checking the data. And then we can keep hitting the optimized pair. We'll click it one more time. We can keep clicking it and it keeps generating stuff, but you'll get to that stage where the numbers just don't change in a large fashion. And it changed very small amount. And then we'll add to the reference. So now we're taking 52. We've added 52. And now we have our next scan, 53. And then now we'll go through, we'll pick the 3 pair. And then we'll just pick a location. Very close, doesn't have to be exact. And the auto align is a check. So once you click your first point pair, so now you didn't have to hit the optimize one, but we'll go through here and then we'll just identify some other common points. And we just always like to make sure our cursor is flashing in there. And once we assign our 3 points, it goes through there. And then we can optimize, or we have our values, and we can review the scans in the reference section. And then we select add to reference. So that's the two examples of we just completed the registration. And now our registration is complete, but that's the registration process in Business Center. So we have our reference stations, the moving stations, and then our options automatically and optimize. All right, so the next stage is that we'll move into the refinement section.
And Dan, when you pick those points, you kind of like to pick them on planes and get different elevations?
Correct, yeah, giving some different elevations, that building face, and then just a nice selection from the entire scan, not isolated in 2 areas. Or I should say picking like right around the building and not using the 360 scan information.
Okay.
All right, so now we'll move into the refinement. So we'll just take all these and then we'll just refine the clouds. So it requires a station to be fixed, so which locks down the scanner XYZ position, so it holds that fixed. So in this case, we'd like to select a station because one station is required to be fixed. Is a scan station that is tied to many scans, not one of a scan out here where it's tied to a few. So in this case, we'll select 16. 16 is a nice scan to select because it's tied to 44, 14, 13, 52, 17. So we have a lot of scans linked to 16. So we're going to fix 16. We'll now unlock all the rest of them. We'll click refine, but this takes takes several minutes. So once this process completes, you then get the option to save your report. And here's our report. We had station 16. Station 16 was fixed. Then we had our overall cloud-to-cloud error of 7 thousandths. And then we can go through the report and then look at the stations. Station 1 is linked to 10, 11, 12, etc. look at the error, overlap, and the confidence. So we can go through here, read the report, find potential scans that are in question. Here's one, station 24, and we have overlap 10%, 57. So, but in the end result is just reviewing the data, checking the features. This one we could go look at scan 24, turn on scan 2 and 3 and compare and just evaluate. But in the end result, it's looking at the scan data. So that is pairwise refinement. And now we'll move into our third project, which is the georeferencing section. So we've already staged this for the pair. We've already paired it up. And so we'll just zoom in, get a look at. So there is the method I use is the region, using the region and then selecting the scan point from the region instead of working in the entire cloud. So we have then all these paired up. And then we look at the residuals here in the list of the points. Then we have our entire cloud there to georeference. And once we're satisfied, select the georeference button. We'll keep our adjustment. And then we'll close the tool. And then we'll go into turn our targets off, turn the default, enable the raw data. And now, I'll step back into plan view. Now we've moved our X7 data to our GNSS and total station data. Change our point size back to small. So there, now we've completed that operation. And then we can look at that in the three-dimensional view as well. And so now we have our boundary marks, our point cloud of the site. And now we're on our project as well. So we're at state plane ground. And now we can go into our georeference section and use our images. So now we have our point cloud, and we can look at it on the original plat before before anything was added. And then we can now also use our vector PDF. Now we can look at the previous survey that was done. And now if, depending on the view on your end, is now we have, there's the building, or the drawing, and our point cloud. And then as we move on forward with our drafting, we can check distances, check the boundary measurements as well. So got a lot of tools here, several good tools to use for comparison and checking the information of previous surveys and our current survey. So, and that concludes the process, taking our X7, bringing it into a georeferenced location. And now we're ready to move forward and use the tools in TBC to create the final deliverables.
Thanks, Dan. So if you, another tip too, when you're out in the field and collecting this, it's kind of a registration assist where you would kind of scan along the building first. That was kind of a lesson learned as well, right?
Yes. Let's hang on one moment. is, we'll just go here, looking at that. Yeah, so this one started here and we came in the street and we worked in, but looking at establishing the building in perspective gives that feature. So your previous scan, and we have that, we have a vertical structure, a good large target for the registration assist to grab onto. Is creating, scanning, and then moving out.
Awesome. And doing it at 4 minutes outside.
Yes, 4 minutes or higher. And then we just reviewed the project, and I will pass that to you.
Awesome. Thank you, Dan. All right, so next up, I just want to talk real quickly about some TBC resources available to all of you for free for the most part. This TBC website and the support tab is a good way to access all the